Welcome to part 2 of function composition. Here we'll be doing 3 word problems from the text, 62, 63, and 64. Number 62, we have the volume V of a cube is a function of its side length x. Then we have x defined in terms of t, which is a function of time. X will be measured in inches and t in minutes. We want to then find a formula for volume as a function of time, instead of as a function of x. The first thing that I'm going to do is just quickly draw out a cube. A cube is one of the most fun things to draw. Square, square, connect. Pretty good. Then the side length of this cube is x, x, x. Because it's a cube, all of the dimensions are the same length. Now, the volume of a cube is side length cubed, base times length times height or depth. It's three-dimensional. Now we have the volume in terms of x. We want the volume in terms of t. Now this seems a little bit weird. I'm just going to go off on a little calculus tangent here. To measure something in like time, that seems very strange. In calculus, as you'll see next year, a lot of times we'll have optimization and related rates problems that deal with something changing over time. So we might have this cube and the side length might be shrinking or enlarging maybe 2 inches per minute, and then we want to see how the volume is changing over time, because of course the volume is not going to change in the same way that the side length is. The volume is going to get larger much more quickly. So that's where we get something measured kind of in time. So we want to get v as a function of t. The other thing that we know is that x equals t plus 1. So we're told that. So we have two functions here, and we kind of want to work through x to get from v directly to t. So what we can do here is actually compose these two functions and find v of x of t. What this means is we're going to find the volume of x of t. So the first thing that we're going to do is replace x of t with what it is. It is t plus 1. And then we're going to plug that into our volume formula. The volume formula says that any input ends up getting cubed. Note that we could have written this volume formula as v of x if we wanted to. So v of t plus 1 means that we are taking t plus 1 and cubing it. Now this is sufficient to write v of t. It could be t plus 1 quantity cubed. You could go ahead and cube that out if you'd like, but this is great. We now have volume in terms of t, whereas from the start here, I'll rewrite this, we only had volume in terms of x. So function composition allowed us to get volume in terms of t instead. Number 63 talks about hot dogs. So a local vendor charges $2 per hot dog. The number of hot dogs sold per hour, x, is given by x of t, and we have a quadratic trinomial here. T is the number of hours since 10 a.m., and it looks like this vendor's only open till 2 p.m., since that's 4 hours from 10 a.m. So the number of hot dogs sold per hour is x, and t is hours. So this x of t function is telling us how many hot dogs are sold per hour since 10 a.m. We then are told that there's an additional function that we don't really know. It says we want to find an expression for the revenue per hour as a function of x. Well, what is the revenue? It's actually given up here, per hot dog. So what we can actually do is come up with this on our own. That's what A tasks us with. We want to find an expression for the revenue per hour as a function of x. Well, what is x? Let's write this out. X is the number of hot dogs sold per hour. T is hours since 10 a.m. Right, so R of X, our revenue, if we're making $2 per hot dog, that's our revenue. $2 times the number of hot dogs, and it is per hour in both cases. So it's 2 times X, and that is part A. For part B, we want to find and simplify R of X of T and figure out what that represents. So R of X of T means that we're doing R of X of T and composing these two functions. X of T is this function here. So I'm going to plug in this function X of T into our R function for X. The R function says whatever input we have, we multiply it by 2. So I'm going to multiply this X of T function by 2. So we'll have 2 times our X of T function. Multiplying all this through by 2 gives us negative 8t squared plus 40t plus 184. So that is what R of X of T equals. We do have to be sure that we put our domain for T on here, since now we're in terms of T, and we do always have to be careful about our domain. We're given this domain. Now, what does this represent? This represents the revenue, R, now as a function of hours, as a function of time, rather than as a function of number of hot dogs sold. So both of these functions give us the revenue or the money made by the local hot dog vendor. However, in part A, this revenue is based on the number of hot dogs sold in an hour, whereas this revenue function is based on how many hours he's been out there. Therefore, R of X of T represents the revenue per hour. All of this is per hour, if you notice. So the revenue per hour, and it's now as a function of time instead of as a function of the number of hot dogs sold. In part C, we're asked to find the revenue per hour at noon. So this is asking for revenue per hour, but it's asking us to plug in a T value, time, which is noon. Therefore, we're going to use the function that tells us the revenue per hour to plug in T, this function here that we came up with in part B. So part C is having us plug in a T value to our new composed function. Since T is the hours since 10 a.m. and we want to know the revenue per hour at noon, T would be 2. So we are finding R of X at 2. Plugging 2 into our function here, we'll have negative 8 times 2 squared plus 40 times 2 plus 184. Simplifying, we'll have negative 8 times 4, then we'll have plus 80 plus 184. This gives us $232. That means that the revenue per hour at noon is $232. This last problem is a discussion problem, and it's a little bit more open. We can talk about how some real-world processes, such as filling out your federal income tax forms or computing your final course grade, could be viewed as function composition. So I decided to take a look at the final course grade, since probably a lot of you are not doing your own federal income taxes, but we could also discuss that too if you're interested. But computing our final course grade, our class is your final quarter grade is determined by, actually, and I didn't see course here, I thought quarter. So let's talk about maybe finding like your quarter grade instead. We could also do course as well. But in order to find your quarter grade, we have 40% of it is how you do on your assignments. We could call that A of X. 35% is how you do on your tests or your test grade, T of X. And 25% of your grade is based on your performance on the quizzes. We could call that Q of X. Now, in order to find those individual grades, you take up to find A of X, T of X, and Q of X, you figure out how many points you got on assignments divided by the total number of possible points on the assignments. Same for tests and same for quizzes. To find your overall quarter 2 grade, which we could call G, what we could do is we take 0.4 times our assignments grade plus 0.35 times our test grade plus 0.25 times our quiz grade. And that is how you can find by hand what your overall course grade is, or rather quarter grade is for our class. And in general, that's how you can find your overall grades for any class that does weighted grades.